Welcome back to another lecture from organic chemistry. So last lecture, we were talking about how to technically get alkyl. And the way we do it, we remove one hydrogen from alkane and whatever left, we call it alkyl. And we said replace A and E from alkane by YL. To say that that species is attached to something, okay? Because whenever you remove hydrogen, there's left over, it will not be acted, so it has to be attached to somewhere. For example, I go with CH4, which is methane, and I remove one hydrogen from it. If I remove one hydrogen, it will give me CH3. Carbon is not going to be acted, so carbon must be attached to something else. And that's the reason I put this dash line there to show CH3 is not acted and has to be attached to somewhere. Okay, so CH4 turned to CH3, and we will call it here. From methane, we call it methyl. So I'm going to highlight, okay, highlight this. Okay, so I said I got YL, and the symbol for it, it will be ME. And from now, anytime we say ME or methyl, we're talking about CH3. Okay, so as you see, at the end of those names, I added YL to say that, you know, those species are attached to something. And the thing that I got rid of it was A and E. That means we had a saturated compound or compound that all carbon were acted, but now they are not, so they have to be attached to somewhere else. Okay. Also, I put a star on some of them to say that we might get more than one structure, and we need to know that one. And you will see maybe by end of this lecture or next one, we will go through the geometry of some of them because they have unique names. But for now, okay, for now, let's go back to how to name compound. We said in order to name a compound, we need to have a main chain. We need to know the main chain. The main chain, it might be linear, it might be just like a zigzag, or just completely open, technically open chain, or it might be a ring. Okay, you need to know how to name that technically, parent chain or the biggest chain. Okay, if it's a ring, just simply use cyclo in the front of each name, and that's going to fix the problem. So we're going to use cyclo to say that we are dealing with a ring. And the first one, it has a 3 carbon. So it's supposed to be pro, means 3 carbons. Okay, this one's supposed to be here, 3 carbon. And now I'm going to say propane. That means I'm dealing with alkane, and I'm going to add E. I'm going to add E at the end to say, and this is, alkane, and it's a hydrocarbon. Okay, it's hydrocarbon. Okay, it's a ring. So we're going to add cyclo in the front of the name to say this is a ring. Because if you don't use the cyclo and you just simply say propane is going to represent something else. And propane, we use it for this compound, CH3, CH2, and then CH3. And what do we have here when it comes to the ring? Ring, you have carbon, you have technically 3 carbons. Okay, those 3 carbons are attached to each other. So let's attach the carbons to each other. And each carbon is going to have 2 hydrogens because the carbons need to be acted. So we're going to add 2 hydrogen to each carbon. And as you see, we are missing 2 hydrogen when we compare it with the propane. So the formula for cyclic compound will be CnH2n, okay, 2n. Well, for alkane, the formula used to be this, CnH2n plus 2. This 2 is gone. That 2 is gone. Okay. So for the cyclopropane, we're going to have C3H. It will be 2 times of it, so it will be 6. And if you compare it with the propane is C3H8. So it has 2 more hydrogens than the cyclic compound. And for the second one, it has 4 carbon. So the correct name for it is going to be this. It's a cyclic. So I go is cyclo. Whenever you say cyclic, you're like you're talking about technically is an adjective, or you want to say that compound is a ring. Okay, cyclo. Okay, the compound is like it's going to be a ring. And then what's the name for it? I have a 4 carbon, so I'm going to say butane. Okay, butane, cyclobutane. And next one, it has 5 carbon. Again, it's cyclic, so you will say I'm dealing with cyclo, and I want to say I have 5 carbons, so I say pentane, and I add E at the end. Okay. So, and all this compound, we are missing, two hydrogens. And the way we make it actually, we make carbon octet, we attach at least 2 carbon to each other. Okay, so then we can, technically reimburse or, make entire of the system octet again. Okay, so now I know how to name a cyclic compound. Okay, next. You have such a compound. First thing that you need to know, right, or the first thing that you have to do is like highlight the biggest change. The biggest change is that one. That's going to be the parent. So you say, this is the parent. Okay. And I need to know from which side I need to, start labeling it, which is good in the, story, but for another lecture. But for now, just simply let's pick the parent and substituent. Okay. The parent will be the biggest change. Whatever attached to that yellow, technically change, or the parent, we call it substituent. The first one, it has just 1 carbon. 1 carbon. This is equal to methyl. Okay, equal to methyl. And what was the symbol for methyl? Methyl, we said, is a carbon that attached to 3 hydrogens. Okay, and the correct name for it, it will be methyl. Okay, again, I'm adding E to the end of the name to say that this carbon must be attached to something. Okay, so this carbon must be attached to something. Okay, whatever. Okay, how about this? Next one, it has a 3 carbon. So because it has a 3 carbon, it will be propyl. Okay, propyl. And the symbol for it, it will be PR. Okay. And you're talking about CH3, CH2, and then CH2. Okay, and this carbon, it will be attached to somewhere else. Okay, and this piece, we're going to call it propyl. How about next one? Next one, it has 2 carbons, so it will be ethyl. Okay, this is going to be ethyl. Okay. And as you see, I keep adding YL to the end of names, that just to say that they are attached to somewhere. Ethyl, the symbol for it is going to be ET. Okay, so sometimes instead of just drawing, like the substituent, we just simply say, like we put the line and then we say ethyl. That means you have 2 carbons there. Okay, what's the formula for it? The formula for it, you have carbon with 3 hydrogens, and that carbon attached to another carbon. Okay, now we have 2 hydrogens attached to it. This carbon must be attached to somewhere else. This piece, we call it ethyl. Okay, that piece is going to be the ethyl. Okay, so I have 3 substituent: methyl, propyl, and ethyl. Okay, now what will happen if I have mix of them? How do I, pick? How do I pick the, the main, technically the chain, or like the parent? Okay, you have to go after number of carbons. The one that has more carbon, it will be the parent. Okay, let's practice some example. Okay, so find the cyclic compound, the cyclic section technically, and also the open chain. From wherever they are attached, just simply put such a thing. Put, like this sign, and start counting them. Okay, on both, start counting number of carbons on both sides. And from here, I'm going to say 1, 2, 3, 4, 5, 6. So this one has 6 carbon. How about the second one? 1, Let me write different color. 1, 2, 3. The one that has more carbon, it will be the parent. So the cyclic compound, it will be the parent. It has 6 carbon. So I'm supposed to say hexane. Okay. Hexane. Okay. And because it's cyclic, we need to write cyclo in the front of it. Cyclohexane. Okay. So correct name for the parent, this is going to be the parent. It will be cyclohexane. How about the substituent? The substituent, it has 3 carbons. So for the substituent, we say, because we have 3 carbons, it will be propyl. Okay, propyl. Why L? Because I want to say this piece, the one I'm going to highlight, this piece is attached to the ring. And how do I say is attached to the ring? I add YL. So from now, YL means attached to somewhere. Okay, attached to somewhere. So if I want to write the name for this compound, it will be this. Propyl. Okay, 3 carbons are attached to cyclic compound, cyclo, that has 6 carbon and it is saturated, and it's made of carbon and hydrogen or alkane. So it will be a propyl cyclohexane. Okay, another one. Okay, again, let's separate them from wherever they are attached to each other. So we're going to separate or break that bond or separate them from there. Okay, and we will count number of carbon on each side. 1, 2, 3. Okay, how about this? This is going to be 1, 2, 3, 4. Okay, so this time the open chain, it will be the parent is made of 4 carbons. So 4 carbon, we're going to say butane, because it has 4 carbon. And how about the substituent? Substituent is made of 3 carbons. So we're and also cyclic. So we're going to say cyclo, and we have 3 carbons. So we say prop. That means 3 carbon. Okay, so it's cyclic, cyclo. Prop means 3 carbons, and we want to say it's attached to somewhere. So we're going to add YL to it, and this is going to represent the substituent. Okay, so the full name, it will be cyclo propyl, entire of this attached to butane. Okay, and this is going to be the full name of the compound. Okay, so I'm going to pause here, and in the next lecture, as I told you, I will go after this fact that why some of this, like compound, some of this substituent do have a star, okay? And because they have a different structure, and we need to know how to draw the structure and what's the name for each specific actually structure. And I will see you very soon. Thank you.